Find the derivative by limiting process, which is another way of saying use the definition of the derivative. So this method involves the definition of the derivative that we learned in the previous video, being limit as h approaches 0 of f of x plus h minus f of x all over h. So this is the definition of the derivative. You do have to have that memorized, and the function for which they want us to find the derivative of is f of x equals x squared minus 5. So now we use our knowledge of function notation. F of x plus h simply means that our input is going to be x plus h in there. I'm going to erase that. So when I set my problem up, I'm going to write f of x plus h as x plus h. So I'm inputting x plus h in for x squared minus 5. So that expression right there is your f of x plus h. Then I'm going to switch colors. We're going to minus f of x. So that part of it will be simple. I will put minus the quantity x squared minus 5, which happens to be f of x. And in that same color, I'll highlight for you so you guys can see those are representative of what I just put there. A representative of the functions as f of x plus h and as f of x, and then all over h. And then from here, it's algebraically simplified. There's nothing you can do to the bottom, but the top we can FOIL out. So what we try to do is come up with an expression where certain things should cancel out and simplify out. So here we see that, switch colors so you guys see this, the x squareds cancel out, the negative 5 and the positive 5 cancels out, and we're left with just limit as h goes to 0 of 2x h all over h, where the h reduces, and we get a limit problem with no h's in it. So if we let h goes to 0, it's not going to affect the 2x. So in fact, my derivative is equal to 2x.